Scientists have discovered the true ferocity of a huge volcanic eruption off the coast of Tonga in January. Research ships found that flows of debris stretching at least 80 kilometres across the seabed.
On November 21st, 2024, something extraordinary happened deep beneath the Pacific Ocean. Ahyi Seamount, a once dormant volcano, exploded with force, sending plumes of murky water to the surface. This violent eruption stunned scientists, but what does it truly mean for the ocean's delicate ecosystem and those living above it? Could this be just the beginning of something much bigger? Is this eruption a sign of more intense volcanic activity lurking below? With each new discovery from the depths, it becomes clear Earth's geological forces are wildly unpredictable. Eruption of Ahyi Seamount. On November 21st, 2024, the deep waters of the Pacific Ocean trembled with an eruption that shook the Mariana Trench and the scientific community. Ahyi Seamount, a submarine volcano that sits in one of the most active tectonic zones on Earth, erupted with a fury that sent plumes of discolored water to the surface, signaling that something extraordinary was happening beneath the waves. But what does an underwater volcano eruption really look like, and why does it matter? To many, the spectacle of an eruption in the depths might seem distant or unimportant, but for those who study the planet's active geological processes, it's anything but. The eruption of Ahyi Seamount was marked by the appearance of massive water plumes swirling up from the ocean's depths. These clouds of murky water were caused by volcanic gases, ash, and other debris that were released into the water column. While the sight of these plumes can be awe-inspiring, they're also a crucial indicator of volcanic activity beneath the surface. It's almost like the Earth's way of telling us, hey, something's going on down here. Thanks to modern technology, scientists can observe these plumes from satellites and ships, gathering valuable data to understand the eruption's power and potential hazards. However, the eruption did more than just leave behind dramatic visuals, stirring the possibility of floating pumice, a light volcanic rock that can form during explosive eruptions. Pumice is so porous and light that it floats on water, sometimes creating vast rafts that drift across the ocean. While pumice might seem harmless, it can have a massive impact on the ocean and the creatures that call it home. Large pumice rafts can block sunlight from reaching the ocean's surface, which disrupts the growth of plankton, the tiny organisms that form the foundation of the marine food chain. So while pumice doesn't pose a direct threat to humans, its effects on the ecosystem can be significant. Ahyi Seamount is located in the Mariana Trench, the deepest part of the world's oceans, plunging down nearly 36,000 feet. The trench itself is a geological marvel, a place where the Pacific Plate is forced beneath the Philippine Sea Plate in a process known as subduction. So why does this matter? Well, this tectonic activity generates massive amounts of heat and pressure, fueling volcanic eruptions like the one seen in November. The constant movement of the Earth's crust in this region ensures that volcanoes like Ahyi Seamount remain active, making eruptions in this part of the world a regular occurrence. In fact, the eruption in November was just one of many, adding to a history of geological activity stretching back decades. In this region, volcanic eruptions like those from Ahyi Seamount are a regular part of the landscape, though they can be difficult to predict. Scientists have been keeping an eye on the volcano, especially after the increased activity in late 2024. But just because eruptions are expected doesn't make them any less powerful or impactful. In fact, it's a reminder of how unpredictable and wild the Earth can be. The eruption of Ahyi Seamount also raises concerns about the delicate balance within marine ecosystems and how small changes like floating pumice rafts or shifts in water temperature can have long-lasting effects. From disrupting food chains to affecting shipping routes, the impact of underwater eruptions can be far-reaching. The ocean, despite its vastness, is a surprisingly fragile system. And events like this one make us realize just how interconnected everything truly is, from the smallest marine life to the ships navigating the waters above. As Ahyi Seamount continues to erupt and scientists gather more data, there's still much to learn about the long-term effects of such volcanic activity. The deeper we look, the more we uncover. Whether it's the release of pumice or the potential disruption of marine ecosystems, these eruptions are a reminder of how much we still don't know about the forces at work deep beneath the ocean's surface. So while the eruption on November 21, 2024 may have been just another chapter in the ongoing story of Ahyi Seamount, it's a story that keeps evolving, offering new insights into the incredible power of the Earth's geology. The eruption on November 21, 2024 raised new questions about the behavior of Ahyi Seamount. Could this eruption be a sign of something bigger on the horizon? As the situation unfolded, experts watched closely, wondering how much more intense could it get. The growing unrest triggered a critical response. What would happen next? The volcano alert level raised. When a volcano like Ahyi Seamount, nestled deep in the Pacific Ocean near the northern Mariana Islands, starts showing signs of eruption, the world doesn't always feel the immediate effects. But the truth is, the ripple effects are felt far beyond the eruption itself. On the heels of the eruption in November 21, 2024, the Northern Mariana Islands Volcano Observatory, NMIVO, made an important decision, raising the alert level for Ahyi Seamount to advisory and its aviation color code to yellow. But what does this really mean, and why should we care about a volcano erupting underwater? First, the advisory alert level. This is a serious step up from normal conditions, but it isn't yet a full-blown emergency. The volcano's activity has shown enough signs of increased unrest to suggest that the situation could escalate, but it's still not at the level where scientists are expecting an imminent eruption. Think of it as a cautionary yellow light, a warning that things could take a turn, but we're not quite there yet. The advisory level is a signal to everyone in the region, as well as those monitoring the volcano globally, that they need to be on alert. Researchers increase their monitoring activities, looking for any signs that the eruption might intensify. So what exactly does this elevated level mean for the surrounding areas? For one, it results in heightened monitoring and more communication between scientists, local authorities, and the general public. While the eruption may be happening deep underwater, the effects can still ripple through the ecosystem and even the air. If magma forces its way to the surface, it could generate ash clouds or, in the worst case, lead to explosions strong enough to disrupt surrounding environments. Even if the eruption is under the sea, its effects can spread to the surface. For now, the advisory alert is a step to keep everyone prepared, but not necessarily panicked. The other significant part of the heightened alert system is the yellow aviation color code. For anyone who has flown near an active volcano, this is a well-known signal. A yellow code means that volcanic activity could pose potential hazards to air travel. In this case, it's not just the eruption itself that poses a risk, but the ash that could be launched into the atmosphere. Ash clouds can disrupt flight patterns by blocking visibility, damaging aircraft engines, and even affecting air traffic miles away from the eruption site. For pilots and air traffic controllers, a yellow aviation code is the signal to proceed with caution, rerouting flights or making adjustments to avoid any dangerous volcanic ash plumes. Air travel, especially in areas near active volcanoes, can become a delicate balancing act. While the eruption at Ahyi Seamount might seem like an isolated incident, the potential consequences can be felt globally. The ash can travel far beyond the point of eruption, as was seen in the aftermath of past volcanic eruptions like Mount St. Helens and Eyjafjallajökull. These eruptions had global consequences, including major disruptions to air travel and the economy. The decision to elevate the aviation color code was a proactive move, a signal that, while the eruption isn't immediately threatening, the situation could quickly change, and authorities need to be ready. What makes the situation even more precarious is Ahyi Seamount's location. This underwater volcano sits within the Mariana Trench, one of the most geologically active regions in the world. It's part of the Pacific Ring of Fire, a vast area where several tectonic plates meet, constantly shifting and causing volcanic and seismic activity. So while Ahyi's eruption might be deep under the sea, its consequences could reach far beyond the immediate area. The eruption could lead to the formation of pumice rafts, which can disrupt marine life and affect shipping lanes. Moreover, if the volcano produces significant ash, it could impact air quality in nearby islands and disrupt flight paths over the Pacific. The eruption itself isn't the only thing to focus on, it's the lasting consequences that follow. Even after the eruption subsides, the aftershocks and changes to the environment can be felt for months or even years. The rise in volcanic activity in recent years serves as a reminder of how fragile our planet's balance is. Ahyi Seamount's advisory alert level and yellow aviation code are a signal to the world that nature's forces are at work beneath the waves, and they may affect us in ways we can't always predict. While we might not always see it, volcanic activity has a far-reaching effect. From oceanic ecosystems to the air we breathe, eruptions like Ahyi Seamounts play a crucial role in the Earth's natural cycles. The elevated alert levels are a stark reminder that no matter how far removed the eruption is from our daily lives, we are all connected by the dynamic forces shaping our planet. As scientists continue to monitor the volcano, we can only wait and see what comes next, keeping in mind the very real potential for even greater eruptions ahead. After all, when a volcano like Ahyi Seamount starts to rumble, it's not just the immediate area that feels it, it's the entire planet. Scientific monitoring challenges. Monitoring an underwater volcano like Ahyi Seamount located near the Mariana Trench is no simple task. Unlike volcanoes on land, which are equipped with seismographs to measure ground movements and predict eruptions, scientists studying underwater eruptions face significant challenges. Imagine trying to monitor an eruption happening beneath thousands of feet of ocean water, where traditional monitoring methods simply can't reach. In the case of Ahyi Seamount, this means relying on tools that, while powerful, have their limits. Unlike land-based volcanoes, which are equipped with extensive seismic networks, Ahyi Seamount's eruption challenges researchers at every turn. The lack of nearby seismic stations forces them to rely on alternative methods to understand the event. And here's the catch. These methods aren't as precise as traditional seismic monitoring, leaving scientists in a bit of a bind when it comes to predicting the eruption's full scale or timing. So how do they keep track? The main tools they use are satellite imagery and hydrophones. Satellite imagery can spot changes in watercolor, temperature, and even floating pumice. These signs provide valuable clues that an eruption is happening below the surface. But while satellite imagery can give a visual snapshot, it can't show all the details about what's really going on deep underwater. It's like taking a picture of a storm from miles away. You know something's brewing, but you don't know exactly what's happening in the eye of the storm. Then there are hydrophones, which are underwater microphones that detect sound waves caused by volcanic activity. These sounds could be explosions, magma shifting, or even underwater tremors. It's as though the volcano is whispering beneath the surface, but it's still hard to hear clearly without all the right equipment. Despite being helpful, these hydrophones don't give scientists the full picture either. They can't measure the eruption's intensity in the same way seismographs would, making it harder to predict the eruption's behavior. As a result, researchers have turned to more advanced technology to help them gather data. Autonomous underwater vehicles, or AUVs, and remotely operated vehicles, also known as ROVs, are two examples. These machines can dive deep into the Mariana Trench, where the pressure is intense, to gather data firsthand. But these come with their own set of challenges. While AUVs and ROVs can provide more detailed images and measurements, they're expensive, require skilled operators, and can't always get close enough to capture everything needed. The extreme conditions of the trench make it difficult to collect the kind of data scientists truly want. Despite these limitations, institutions like the National Oceanic and Atmospheric Administration and global research teams continue to push the boundaries of what's possible. And while they've made significant strides in understanding underwater eruptions, they're still far from getting the complete picture. With technologies like hydrophones and AUVs, they can detect volcanic activity and measure seismic disturbances, but the data is still limited and many questions remain unanswered. What does this mean for the future of volcanic monitoring? Well, it's clear that while progress is being made, there's still a long road ahead. Scientists are continuously improving these methods and discovering new ways to monitor underwater eruptions more effectively. But the reality is, monitoring volcanoes like Ahyi Seamount, especially in a place as deep and remote as the Mariana Trench, requires time, patience, and a lot of ingenuity. Until more precise and accessible tools are available, researchers will have to keep relying on the technologies they've got with all their limitations. In the end, though, the discovery of an eruption like the one at Ahyi Seamount is a reminder of how much we still have to learn about our planet. While it might be difficult to track, the knowledge we gain from these eruptions helps us better understand the forces at play beneath the ocean's surface, and ultimately, the mysteries of our Earth. So while scientists may not have the perfect tools to monitor underwater volcanoes just yet, each new eruption provides a new piece of the puzzle. Geological context. Ahyi Seamount, an underwater titan, is hidden deep beneath the Pacific Ocean, but don't be fooled by its submerged location. This volcano is no stranger to action. Rising to within 75 meters of the ocean surface, Ahyi Seamount is part of the Mariana Volcanic Arc, a series of volcanoes formed in one of the most intense geological zones on Earth. So what makes Ahyi so restless? The answer lies in a powerful geological process taking place beneath the waves. The Mariana Volcanic Arc is located at a subduction zone where the Pacific Plate is slowly being pushed beneath the Philippine Sea Plate. This process, known as subduction, creates an immense amount of heat and pressure as the plates collide. The oceanic crust of the Pacific Plate sinks into the mantle where it melts into magma. This magma then rises toward the surface, fueling volcanic eruptions along the Mariana Arc. It's as if the Earth is always simmering a cauldron of molten rock, with volcanoes like Ahyi serving as the vents letting out the pressure. The ongoing subduction means magma is constantly replenishing the volcano, making it highly active and prone to frequent eruptions. The location of Ahyi in such a geologically active region explains why it erupts more often than volcanoes found in other, less active zones. But Ahyi is not the only volcano with a powerful yet hidden force beneath the ocean. Take Hunga Tonga Hunga Hayapai, for example, another submarine volcano but one that lies in the Tonga Kermatic Arc, where the Pacific Plate dives beneath the Indo-Australian Plate. Both regions are tectonically active, but the eruptions they produce can differ dramatically. In 2022, the eruption of Hunga Tonga was so powerful that it sent shock waves through the atmosphere and generated tsunamis that reached distant coastlines across the Pacific. This level of destruction is rare, especially compared to Ahyi's eruptions. Imagine the sheer power of a volcano that could affect the global weather system and send waves around the world. While Ahyi's eruptions tend to be more localized, the massive energy released during a major eruption in the region could have similarly wide-reaching consequences. But there's another element to Ahyi Seamount's eruptions: their impact on the oceanic ecosystem. What happens when a volcano erupts beneath the sea? The sudden release of magma, gases, and minerals into the water can alter the local chemistry of the ocean. This can affect everything from the water's temperature to its acidity, and in some cases even the local marine life. Many rare species of fish and other marine organisms live near the volcanic vents, relying on the minerals and heat emitted by the volcano. However, an eruption can also cause rapid changes in the environment, leading to the destruction or displacement of these ecosystems. The eruption of Ahyi, while significant, often goes unnoticed by the world beyond the scientific community. But deep below the ocean's surface, the volcano's influence is anything but invisible. Despite its remote location, Ahyi Seamount's eruptions are not isolated incidents. They are part of the continuous geological process that shapes our planet. So why should we care about a volcano that lies so far beneath the surface of the ocean? The answer lies in understanding the underlying geological forces at play. By studying these volcanoes, scientists gain a deeper understanding of the Earth's tectonic processes, the movement of magma, and how these factors contribute to the formation of new landmasses, earthquakes, and even tsunamis. The insights gained from monitoring Ahyi Seamount and others in the Mariana Arc help us prepare for the unpredictable forces of nature that, though hidden from view, shape our planet in ways we're only beginning to understand. As we look toward the future, the volcanic activity of Ahyi Seamount serves as a reminder of the immense power of Earth's geological processes. While the eruptions of Ahyi may not always make headlines like other catastrophic volcanic events, their potential impact on the environment and human activity cannot be underestimated. This hidden giant beneath the Pacific Ocean continues to remind us that even the most remote and quiet regions of our planet can unleash powerful forces, changing the world as we know it in a split second. Historical eruption records. Beneath the vast expanse of the Pacific Ocean lies a force of nature that refuses to be ignored. Ahyi Seamount, a volcano whose eruptions have long reminded us that the Earth is still alive and constantly changing. Imagine for a moment being on a fishing boat near this remote underwater mountain in 1979, when suddenly the ocean beneath you trembles with strange vibrations and the water turns sulfurous. This wasn't some ordinary day at sea, it was the first sign that Ahyi Seamount was waking up. From that moment, it became clear that this volcano wasn't just a dot on a map. It was a living, breathing force ready to shape the ocean's surface. By the time 2001 rolled around, Ahyi had proven just how powerful it could be. Seismic stations as far away as the Tuamotu archipelago picked up signs of a major eruption, sending ripples of alarm throughout the Pacific. It was more than just a blip on the radar. It was an event powerful enough to send seismic waves across hundreds of kilometers. This eruption didn't just rattle the ocean, it marked Ahyi Seamount as a volcano to watch closely. The force behind this eruption was so intense that it made its presence felt beyond the immediate region, making it clear that this wasn't a dormant volcano but one still actively shaping its surroundings. Then between 2022 and 2024, Ahyi Seamount erupted once again, continuing a pattern of activity that stretches back for decades. But here's the twist. These eruptions aren't isolated events. They're a glimpse into a much larger geological story, one that has been unfolding for millions of years. Scientists have closely monitored Ahyi's activity, and with each eruption, they've learned more about the powerful tectonic forces at play beneath the surface. These eruptions aren't random, they're part of a continuous cycle that speaks to the ongoing geological activity at play in the Mariana volcanic arc. However, Ahyi's eruptions aren't just a scientific curiosity, they've had real-world effects on the people and ecosystems around them. The 2001 eruption, for instance, disrupted nearby communities, and scientists believe that the volcanic activity has had lasting impacts on marine life. The ocean around Ahyi, teeming with life, would have been dramatically affected by the changes in water chemistry, temperature, and currents. In some ways, the eruptions of Ahyi serve as a stark reminder of how interconnected we all are with the natural world. The sea, which provides life to so many, can also be a force of destruction when the planet's tectonic plates shift and stir up the ocean floor. What makes Ahyi's eruptions even more fascinating is the deep cultural connection the Pacific people have with the ocean and the volcanic activity that comes with it. Ancient islanders living in the shadow of these powerful volcanoes passed down stories and legends that reflected their intimate knowledge of the dangers of the sea. These stories weren't merely folklore, they served as warnings, passed down through generations to help future communities understand the sea's volatile and unpredictable nature. Today, as scientists use cutting-edge technology like seismic stations, satellites, and hydrophones to track volcanic activity, the ancient wisdom of Pacific Islander cultures still holds value, reminding us that nature's power was recognized long before modern science came to understand it. And it's this rich history, both scientific and cultural, that helps us understand Ahyi Seamount today. While the volcanic activity continues to be closely monitored, there's still much that we don't know about the forces shaping the deep-sea ecosystems around the seamount. Each eruption, each tremor beneath the surface offers new clues about the planet's geological history, but also raises more questions. Will Ahyi erupt again with the same force? What will the next eruption mean for the people living in the region? These questions are more than just scientific. They're part of a larger narrative about the Earth's power and the ongoing dance between humans and the natural world. While science continues to uncover more about this mysterious seamount, we can't help but respect the ancient knowledge that has always seen the ocean as both a source of life and a force of destruction. Ahyi is not just a volcano, it's a symbol of the raw power that lies beneath our feet, constantly evolving, never predictable, and always reminding us of the mysteries that still lie ahead. And so the eruption of Ahyi Seamount is far from over. As scientists continue to monitor this volatile event, it's crucial for us all to stay informed and prepared. The choices we make now will impact how we face future geological challenges. What do you think? Are we ready for what lies beneath? Share your thoughts below. Hit like and subscribe for more insights into our ever-changing planet. Stay curious and keep exploring the mysteries of the deep.